All right, so as I was saying, just at the very end there, the values of the chi-square are not negative, everything's greater than 0. Now, let's think about the implications of this for just a tiny second. Because this graph, the chi-square distribution, excuse me, is not symmetric, that means that you're not going to be able to make a confidence interval the way we have for all the other sections. Look, I say all the other sections, it was really 2 other sections, but bear with me. It won't work like this. It won't work like point estimate plus or minus margin of error. It's not going to happen. So what's going to happen is you're going to need to find 2 different critical values. And unlike the t and the z distributions, these are not going to be symmetric. So when you find one, you've only found one of them, and you still have to go find the other one. Now, there's a table to do it, but you also have Excel. And Excel can do it for you quite nicely. So let me show you how. We're going to find the critical values for a chi-square distribution. I just want to make this Excel a little bit smaller so I can see what I'm doing. There we go. Move it down. Okay. So I want it for a 90% confidence level. So let's just write down some things. My confidence level is 90%, 0.90. My decimal point button didn't want to work there. Okay, so that means, let's start with this. What's alpha? Alpha is 1 minus that. So then alpha over 2 is equal to that divided by 2, right? All right, and while we're on the subject, 1 minus alpha over 2 would be equal to 1 minus alpha over 2. Okay, now why am I finding alpha over 2 and 1 minus alpha over 2? Well, look at these chi-squares. See how one's got a 1 minus alpha over 2 and the other one's got an alpha over 2? See that? That's why. Okay. Now, what about n? N was 16. So df, degrees of freedom, is equal to 16 take away 1. Okay, we're going to need all of those numbers in order to find our chi-squares. So let's find chi-square. Okay, oops, let's do it for the alpha over 2. Let's find that one first. All right, how do we do it? Well, if you type CHI, you're going to get a whole host of things. Now, because I'm working with the 2010, I have a few more things at my disposal than you have necessarily when you're working with Excel 2007. Excel 2007, you're stuck using chi-inverse, which I don't like as much as chi-square, this one, chi-sq.inv. Okay, now what does it want? Well, it wants the area in the tails, right? So that would be alpha over 2, and wants my degrees of freedom, which would be 15. Press enter. All right, and there's one. Actually, I made a mistake. It's not a really big mistake, but this is actually the 1 minus alpha over 2 one that we found. Just because of the way the chi-square inverse function works, that's how it's going to be. If you're stuck with the old, it's really not as nice. Chi-inverse returns the inverse of the right tail probability. So you could take that, and let's see, type that, 0.05, 15, let's see what happens. Right, that's actually the other one that's going to go with it. See, and this is why the old ones and the new ones just aren't quite the same as each other. So this is actually the other one, but I can just leave it. This is the 1 minus, or the alpha over 2. This particular one was the 1 minus alpha over 2. Let me show you how to do it, the 1 minus alpha over 2 again, just a different way. Let me move this down. So if you want to find the other one, alpha over 2, you type equals chi square dot inverse, that one. And you can actually tell it a couple things. But my favorite one to pick is the chi-square dot inverse dot rt, which would be the opposite of the one we already found. So you'd say 0.05, which is alpha over 2, comma 15, enter, and there it is. So that helps with that one. Now chi-inverse finds this one. To find the other one, you'd have to go, oops, I'll have to finish that in the next video.